Okay guys, this is the second video, well the second part in the three-part series on elements, compounds and mixtures, and we're focusing on mixtures right now. There are two types of mixtures, and this is what I want to zero in on today. And I don't want to sort of get you scared of big words, okay? I'm going to reveal a very deep, meaningful scientific description here, okay? The first type of mixture that you need to know is mixtures with bits that you can see. Right? Now don't get intimidated by those big words there. Right? One type of mixture is basically mixtures with bits that you can see in them. For example, these guys. Let me get that up a little bit for you. Right? All of those are mixtures, right? Mixed lollies, you can obviously see that there are different types of lollies in there, right? Mixed gravel, you can see there are different types of stones in there. It's obvious that it's a mixture. Even Milo and milk, you can see the milk, you can see the Milo, you can see that there is at least two different types of things in there. Easy. Okay, the hard part is the actual scientific name for this. This type of mixture with bits that you can see, I mean, that's the definition I like, but we need to do the scientific definition as well. This is the word, heterogeneous. I know. Hetero means different, right? And you can see the different parts of these mixtures, right? Now, by the way, that doesn't say genius. That isn't pronounced heterogeneous. It's heterogeneous. That actually says genus. I don't know why, but it does. Right? So a heterogeneous, or a heterogeneous to be correct, mixture, you've got me doing it, is a mixture where you can see that it's a mixture. You can notice different parts, different types of particles in things, because the particles are enormous lumps that even human eyes can pick up. All right. Now, no prizes for guessing the second type of mixtures. They are mixtures with bits that you can't see. Oh my God. Okay. But can you guess what the word must be? Right? It's not heterogeneous. Okay, mixtures with bits that you can't see. Firstly, let me show you one. Exhibit A, a glass of milk. Right? Now, milk is a mixture. It's got water in it. It's got fat in it. It's got lactic acid in it. It's got some vitamins. It's got some minerals. It's a mixture of a good dozen or so different things. But to look at it, it looks like it's pure. Right? One glass of milk, every little bit of it just looks like white creamy stuff. You can't pick it. You can't point to it and go, oh, there's a lipid now. You can't pick it and say, oh, there's a bit of fat, there's a bit of water. I can see the different bits. Right? These parts are so small they've become microscopic, and so you cannot tell which part you're looking at when you look at a different bit of the milk. It just all looks the same. Right? So this is a smooth, blended mixture that is so well blended that as far as our eyes can see, it doesn't look like it's a mixture at all, but it is one. It's a homogeneous mixture. Let me just get that all in the picture. There you go. Again, homo means the same, just like hetero means different. This one all looks the same. You can't tell that there are different bits. And again, it doesn't say genus, it says genus, homogeneous. Now, there are two types of homogeneous mixtures. Milk is one of them. Milk is a suspension. Right? Now, suspensions, they do have microscopic pieces of things floating together. Right? So the particles are too small for us to see. But remember, excuse me, but the particles themselves are not entirely one particle by themselves. Remember these guys? Right? These are individual particles. Now, if you could see the lumps of fat and the lumps of stuff floating in the water in milk, they wouldn't look like that. They look a little bit like this, okay? So they're not single particles all spread out apart from each other. They're still great lumps of stuff, but that is still microscopic to our eyes, so we can't see it, right? That sort of mixture is a suspension, right? Lumps that are too small for us to see, but they're not entirely separated, right? There is one more type of mixture that also has bits that you can't see. I'm just going to show you this beautiful picture here. There you go, underneath a swimming pool. Swimming pool water is a mixture. It's not all H2O, right? Pure water is all H2O, but this stuff has obviously got a few things in it. It's been chlorinated for a start. It's probably got some salt in it as well, and it's probably got a few bits of human skin in it, not to gross you out. But the particles that are in here really are a little bit more like this. They really are separated entirely. Right? So this is the most extreme mixture that a mixture could possibly be. This is as mixed as it can get. Right? Now, this particular type of mixture, when the particles are completely separated, and it's not a great lump of stuff, they're all apart from each other. This has a special name. This is called a solution. And I'm going to do another video on solutions themselves because there's a fair bit to learn about these next. But for now, that's it, folks.